Okay, so we're just going to look at a couple of quick things there before you start work on that sheet. The first one I'm going to touch on, let's take a look at this example here. I'll redo this one, and I'll use the grouping method, which is done by the textbook. The grouping method is going to be, oops, sorry. The grouping method is good. If you understand how factors work, it's the smarter way of doing things because it's more general purpose. But sometimes general purpose means it's more work because it works for more things. So my suggestion to you is if you like it better, go for it. But if not, I think you'll find the mystery method is enough for us in our course anyways. But basically what we're going to do is we start off the same way by multiplying the first and the last, and we just think about this number here, 10, okay? How does 10 connect to 11? Well, remember, normally we want two numbers that add up to 10, or sorry, add up to 11 and multiply to 10. So we're playing a similar game. Only instead of writing it out like this as x squared plus 11x plus 10, we're not going to cheat and change the question. What we're going to do is write this in groups. So I'll show you how the groups are going to look. Now, the numbers that add up to 10, or sorry, add up to 11 and multiply to 10, those were 10 and 1. So this is where we start to differ. This is what you would have done in the mystery method, and then you continue on with the fractions. Here's the way it looks if we do this on the grouping method. Your textbook goes like this and says, these are the two numbers that I'm concerned about that I want to form groups with. So what I'm going to do is I'm going to rewrite this in this form. Okay. So I'm going to make two groups, hence the name of the grouping method. And I'm going to try to factor out all the common factors. So here I can take out a 2x. So this will be x plus 5. And what you'll notice here is there's an x plus 5 on this piece and an x plus 5 on this piece. So now I can factor that out. So I would end up with x plus 5 times 2x. And there's an invisible 1 here, right? 1 times that. So 2x plus 1. So that's how your textbook would get the answer. And this example I chose because it works out fairly nicely for grouping. That answer will be the same. But there are cases, like I think if you were to try this one or this one here, grouping will work, but it's much more difficult than the mystery method. So again, it's up to you, but if you notice your textbook notes, this is the method your textbook uses. It will separate them into groups and then factor out as much as it can, piece by piece, until it ends up with an answer like this. Okay? So, the only extra step we need to take now if we're going to be solving these quadratic equations, the one that we just worked on, if this was, oops, sorry, it's 11x, that last one that we were just working with, we just had a factored form. Okay. Now, usually when we want to work for solving a quadratic equation, we're interested in solving this form when it's equal to 0. So the way we do this is we start by factoring it. Just like you've been doing. And the reason we factor it is now it's easy to think about how to make this equal to 0. To make this piece equal to 0, if I make x equals negative 1/2, then this piece here is a 0, and 0 times anything is going to give me a number for 0, right? So that way it cancels everything out and the whole equation equals to 0. On this one here, same thing. If I chose x equals to negative 5, that would make this piece equal to 0, which means 0 times anything knocks out this whole equation to be equal to 0. Okay? So let's go one step further then with this last one. This is what we had. If we were to solve this as 4x squared minus 12x plus 5 equals to 0, what would the solutions be? Okay, if you're on the right track, let's just see here. How many solutions are there going to be? You can hold up a hand and say either like this or like this, or how many solutions do you think there are going to be? Okay, so far people are on the right track. There should be this many. Okay, there should be 2. And what I'm looking at here was the factored form where it equals 0. So the first one, when 2x minus 5 equals to 0, and the other one when 2x minus 1 equals to 0. So for this piece, when x equals to 5 halves, and on this piece, when x equals to 1 half, this would be 0, knocks the whole equation out. Or this would be 0 at 5 halves, knocks the whole equation out. Okay, so for solving, that's all we're going to do. You may have to rearrange your answers, but basically this is the form you want to start with. Okay, so let me just see that one for 1 second. Let's try one a little further down your sheet together, and then I'll let you get started on it. So let's take a look at number 20. Okay, so we'll take a look at number 20, which is 7r squared equals negative 64 plus 64r. So the first thing you should notice about it is it's not ready to go, because this is the form we're going to work with before we factor. Everything's set up equal to 0. Why does it have to be equal to 0? Well, this won't work unless we're trying to make both sides equal to 0. Right? That's the reason that we want to factor it. It's easy to find where things equal 0. But if this said equals 5, well then it's hard. It's not as easy of a problem. Okay, so to set it up, the first thing we do is we go 7r squared minus 64r plus 64 equals to 0. Now it's in a standard form that we can solve it. Okay. So you're probably going to want a calculator for this, because those numbers are going to start to get big very quickly. But 7 times 64, I don't think there's any common factors there. And yikes, that's a large one to try to factor here. Let's see, how about 16? What do I get for 16? 16 and 28, nope, that won't do it. 56 times 8, okay. So 56 times 8, I believe I'm going to need both negatives then. And 56 here. Now remember, this is not the answer. It feels like we've got an answer because it's factored, but do you remember what I said everyone forgets to do when I look at their quizzes and tests? Divide, yeah, we forget to divide. So I have to divide by 7 in order for this to work properly. I multiplied at the beginning, so I got to divide this time. So if I reduce them, I end up with r minus 8 over 7, so it doesn't reduce, and r minus 8 equals to 0. So that means I end up with 7r minus 8 and r minus 8. So my answers is going to be when this one equals to 0, which is at r equals 8, and when this one equals to 0, which is at 8 over 7. So those are my two answers for that question number 20. So I'm going to let you take the rest of the block to work on that, and if you have any questions, let me know.